So these are the PowerPoint slides. And again, they have the same kind of information as the notes, but the notes is just more condensed, right? Okay. So, oxidation reduction, and then here is the TXI stuff. Okay. Maybe actually, you know what? You can go through the concept chart question yourself, and I'll post the answer later on. All right. I think that's probably more efficient use of time. Okay. So now, for the rest of the class, let's let's talk about the first three stages. Okay. Like I said, I don't think I have time for the fourth stage. So let's talk about glycolysis first. So, do you remember from the first half of the lesson, where does glycolysis happen in? That's right, the cytoplasm. Happens in the cytoplasm. Glycolysis is actually considered as anaerobic. Anaerobic. Meaning it can happen without oxygen. It can happen without oxygen. Now we can split the word into two parts. Glyco means sugar or glucose in this case. Does anybody remember what lysis means? We learned this last week. To break, exactly. So if you put two parts together, glycolysis is basically to break glucose. Okay. How many carbon atoms are there in a glucose molecule? 6. So if you break it into two equal parts, how many carbon in each? 3, exactly. So basically, in glycolysis, you're taking glucose, which is 6 carbon, and we are splitting it into two equal halves. Each half is called a pyruvate. And this happens in the cytoplasm. Okay. One glucose is split into two pyruvate. Actually, I don't know. Is the past tense of split also split? Split? Sorry, is it with DD? I don't know. My English is also not very good with the grammar and stuff. I think it's just split. Yeah, okay. Thank you. One glucose is split into two pyruvate. Okay, what else can we tell? Okay, so there are actually two there are actually 10 steps, okay? But we're not going to learn the 10 steps. Right? We can separate the steps into first 5 steps and last 5 steps. Okay. So we have energy, investing phase, which is step 1 to 5. And then we have energy yielding or energy producing phase, which is step 6 to 10. You might have heard the phrase, it takes money to make money. If you put money in the bank, they pay you interest. You get more money from it, right? Okay. So that's what happens here. We cannot just make ATP without investing anything. Okay? In fact, in lecture 2, I showed you for a chemical reaction, you have to supply a little bit of energy, right? To begin before it can take place. And that's what happens here. In the first 5 steps of glycolysis, we are investing some energy. Okay? So 2 ATP molecules are invested, are used to energize glucose. Okay. And then from the energy yielding phase, you're going to get 4 ATP and 2 NADH are produced. All ATPs produced here are through SLP. So that's where you have the enzyme. You're going to transfer the phosphate onto the ADP. It's not the common method. Remember, only about 11% are produced this way. So let's think about this. We invested 2 ATP and then you get 4 ATP back. So how many did you actually make? But you invested 2 though. You only make 2, right? Okay, it's like if you give me $200, I give you 400 back, you only gain 200 net, right? Right. So we say gross ATP is 4. Gross is before you subtract your expense. Okay. Net is 2. Okay. Net is 2. Make sense? So then let's write this down. Net ATP reduction 2 ATP. Right. Now I want you to take out a separate piece of paper where we'll be summarizing these things as we move along. And I'm just gonna, you know what? I'm just gonna start a new page as well, and then I'll put them together for you. Okay. Do I have an old one to show you? No, I don't think I have an old one. Okay, but basically it's gonna be like this. If this is your paper, okay, we're gonna start up here, and then we're gonna split the glucose, and then the glucose is gonna become the pyruvate, and then we're gonna do a bunch of stuff to it, and then it's gonna have like 2 big circles. Okay, so just so you plan out the space accordingly. So separate piece of paper, we're gonna call it cellular respiration summary. So glucose, which is 6 carbon, it's going to become pyruvate, 3 carbon. And this is glycolysis, which happens in the cytoplasm. So in this process, we have to invest 2 ATP first. You got to charge up, we got to energize the glucose. So when you use up the ATP, they become ADP, right? ADP plus the phosphate, of course, but I'm just gonna keep it simple. And then in the yielding phase, you're gonna produce 4 ATP. And so this is money you invested. This is the return that you get back. But actually, you get back more than you invested. Right? 2 ATP doesn't sound like a lot, but hey, don't forget, you also are able to generate some NAD. So 2 NAD is going to become 2 NADH. Okay, I want to check to see if you remember. NAD is electron carriers, right? So as we break glucose into the pyruvate, it's going to be releasing electrons. NAD is going to capture it, which then turns itself into the NADH. Now tell me, where will the NADH go next? Where is it going to? That's it. It's going to go to the ETC. It's going to go to the last step, right? The airport, right? And where you will use these electrons to produce a huge amount of ATP. 90% of it are produced this way. Okay, that's all you have to know for glycolysis. I'm like, I have to teach you all these details, but I'm not gonna test you on like all the very, fine stuff. Okay, I'm gonna ask you general things like where does glycolysis happen, and then you're like, oh, cytoplasm. Okay, I'm gonna ask you how many ATPs are produced net, and you're gonna say 2 ATP, right? Fantastic. Okay, I'm gonna go back to the other note. Step 2, stage 2. Oh, I just wrote 1. Okay, so I'm just gonna write 2 here. Stage 2. Okay. Stage 2 is called pyruvate oxidation. Okay, so not surprisingly, stage 2 is called pyruvate oxidation because we just created pyruvate from the first step. And the next thing we're going to do is we're going to oxidize it even more. We're going to rip more high energy electrons from it. Okay, so 3 things happen here. 3 steps. Oh, first of all, this takes place where? That's right, in the matrix. Actually, I am sorry. Let me add one extra note here. Okay. When O2 is available, pyruvate will go into the matrix. So then I guess like obviously then it takes place in the matrix, right? I guess we don't really have to write a second step, but whatever, I'll leave it there. Now you may wonder, hey, when would oxygen be unavailable? Right? Well, imagine running at full speed, right? How long can you sustain that? Right? Like if you run at full speed, right? For an average person, maximum speed you probably can keep it at 2-3 minutes tops, right? Okay, unless you train for sprinting, right? And even so, you won't be able to keep it on forever, right? So imagine running at full speed and you've been doing this for like 2 minutes now, then your leg starts to hurt, starts to, feel like can't go on anymore, right? So at that point, your muscles in the legs are using more oxygen than you can supply. Right? And that's a situation where you might not have enough oxygen going to the muscle. Then your body cannot do pyruvate oxidation. Right? It switched to something called fermentation. Okay, you might have heard of, after like a strenuous exercise, after working out, your body has lactic acid, right? Which causes you to become sore the next day. That's basically what happens when you don't have enough oxygen. Okay. So we are going to focus on what happens when we do have enough oxygen, which is like right now. Okay. Your body is burning glucose as we speak. So those pyruvate are going to go to the matrix and it's going to do pyruvate oxidation. So there are going to be three steps. Three steps. Okay. So first step is remove CO2. Second step is to create, whatever you want to say, generate NADH. Right? Because remember, when you are oxidizing something, you're ripping electrons from it. And we don't want to lose those electrons because they're full of energy. So we got to capture them with the energy carrier. Okay, I'll explain the last part here after you finish copying down. So let's backtrack a little bit, right? At the beginning, we had the glucose molecule. We energize it by investing how many ATPs? Two ATPs, right? Okay. But then we got some money back, so to speak. We got some energy back already. We got 4 ATP back. We got some NADH. And in this step, we actually get even more NADH. Remember, each NADH is equivalent to how many ATP? 3, right? Okay. So we actually get quite a bit of return, right? Okay. So by now, at this point, the molecule is kind of out of juice. Okay. It's not really energized anymore because we have been harnessing so much from it, right? So we need to give it a little bit of a boost, which is what coenzyme A is for. Coenzyme A is basically going to re-energize the molecule so that it could go further. Okay, it's kind of like refueling the tank, if you would. Okay, so addition of coenzyme A, which re-energize the molecule for more reactions. Okay, let's go to the summary next. So here is a potentially confusing part, okay? In the notes I just wrote, I said, produce carbon dioxide, produce NADH, but that is for one pyruvate. Okay? Remember, we get two pyruvate from each of the glucose. So from the glucose, each of the pyruvate will undergo those three steps. Right? So we will have, first of all, let's use a different color for carbon dioxide. You're going to remove carbon dioxide. Okay. And then we are going to take NAD, capture some electron to become NADH. And I told you by now it's a little bit out of juice, not going to have as much energy. So we're going to add the coenzyme A to recharge it. And it's going to happen exactly the same for the other guy. Okay, so this is pyruvate oxidation. And where does it happen again? Matrix. So you actually create two NADHs and then two carbon dioxide. Okay, I have another question for you. I know I have a lot of questions, but how many carbon dioxide are we supposed to create in total in the reaction? Not quite. How many, sir? 6, right? Do you remember, guys? Let me go back here to show you. All right here. There. So glucose plus 6 oxygen, 6 carbon dioxide, 6 water. Hey, just remember 666, right? Evil number. So then, right now, so far, we've only created 2 carbon dioxide, right? 4 more to go. Did we create any water yet? No, nothing. Okay, so still waiting. All right, so the pyruvate will become something called acetyl-CoA. They are just names, okay? Don't get too hung up on them. Okay, I'm not going to ask you to describe these things. They're not going to be in the short answer questions, okay? But you do have to understand them to answer the multiple choice. How many carbon atoms in acetyl-CoA? How many? 2, right? Because pyruvate has 3. You remove a carbon dioxide. Carbon dioxide has 1, right? 3 minus 1, 2. Do we have any questions? Again, if you want to read about this, just read the PowerPoint slides. They're all there. That's right. Right. So for every glucose, we're going to get 2 NADH, okay, from this stage. We're almost there. It's okay. It's not too bad at all. Maybe a little bit bad. All right. So next, what's the name of the next step? That's right. So you will continue the reaction in the matrix. You're already in the matrix, by the way. So we're just gonna continue it over there. And each of the coenzyme acetyl-CoA will go through the cycle once. Meaning, that's what IE means, by the way. Okay, a lot of people think IE means an example, but IE means it means. Okay? So goes through the cycle once, which means it's 2 cycles per glucose. Okay? Remember, glucose, you split them. Each pyruvate will become acetyl-CoA, and each acetyl-CoA will do its own spin. Okay? Each Krebs cycle produces 2 CO2, 6 NADH, 2 FADH, one FADH2, and 1 ATP. Right? So these are numbers to remember for the test. All right, so I'm going to show you the PowerPoint slides just briefly so that you have an idea of what it looks like. You don't have to go back, okay? You just watch me do it. So that's the actual Krebs cycle. Like, obviously, we're not going to learn all the steps. This is the simplified version, okay? So, again, you don't have to write anything. You can just watch. We have the acetyl-CoA, remember? That's from step 2, right? That has 2 carbons in it. The acetyl-CoA is going to combine with this 4-carbon molecule. It's already there. This molecule is called oxaloacetate. It's in the note somewhere here. There. Okay, oxaloacetate. Name is not important, okay? What's important is that it's already there. It has 4 carbons. So when the acetyl-CoA comes in, 4 plus 2 gives you 6. This is 6 carbon. Okay? This thing is called citric acid. All right? That's why it's also called citric acid cycle. Citric acid. You'll find citric acid in like fruits, right? Okay, like sour stuff, like orange, lime, whatever, right? So that's gonna be 6 carbon. And then we're gonna break it down more as it goes through the Krebs cycle. Specifically, we're gonna break it down into 2 carbon dioxide, right? So 6 minus 2 gives you 4. After you get 2 more carbon dioxide out, you actually recreate the 4-carbon molecule so that it can combine with another acetyl-CoA, and that's why it's a cycle. It just keeps on going and going. Okay? In the process, you're going to create ATP. You're going to create the 3 NADH that I told you about and the 1 FADH2. Okay, so let's put this on the summary sheet, and then I'll tell you a little bit more. Okay. I actually wrote it wrong here. This should be a 3. I'm so sorry. 3 NADH. Okay, because I was thinking about 2 cycles. So please fix that. 3 NADH, 1 FADH2, and 1 ATP. Here, I'll write in a different color here for you. Per glucose, it's going to be 4 CO2, 6 NADH, 2 FADH2, and 2 ATP. Okay, so we're just gonna go back to here and we're gonna finish the note, and then it will be it. Okay, so this is going to be a cycle. It's going to be a cycle. The acetyl-CoA is going to be coming in. It's called the Krebs cycle. Krebs is the person who probably helped discover this thing. So never mind the 4-carbon thing and the 6-carbon thing. The key thing to remember here is that you will be releasing 2 carbon dioxide. And if you're following the color code system, then this is going to be 3 NAD becoming 3 NADH. This is the only place where you're going to be creating FADH2. And you will also be making 1 ATP. I should mention, this is also SLP. These ATPs are created by the enzyme transferring the phosphate from a donor onto ADP. So this happens twice per glucose. So there we have created 6 carbon dioxide, right? 4 from the Krebs cycle, 2 from the pyruvate oxidation, a total of 6. Okay. How many ATPs have we made so far? Net. How many net ATP have we created so far? Please count and let me know. Like don't count the energy carrier, okay? We're just counting the ATP. How many net ATP have we produced so far? I can see 2 here, but what about early on? How many so far? 4. That's right. Okay. We have 2 from here, right? 2 net, none from the second stage, and then 2 more here. So that's 4 net ATP. 4 out of what? 36, right? 4 out of 36, right? 4 over 36 is 1 over 9, which is 11%. So 11% of the ATP are produced by SLP. We roll it down. So we're still missing a bunch of ATPs. And to get those, we have to do oxidative phosphorylation at the ETC. Okay? And that's what we're going to learn next time. Now, before we go, though, we have to do this question together. This question is really important. Oh my goodness, too big. 1 second. Whatever, I'm just gonna do it over here, okay? Can I copy it maybe? There we go. This is an important question to understand, okay? There are at least 5 marks associated with this concept on the test. So we have to understand, okay? What is the maximum number of ATP that can be produced with 5 turns of the Krebs cycle? So not just the direct production of ATP, we gotta count the energy carrier as well. Because remember, those NADH, those FAD, they're gonna go to the stage 4 and they're gonna make more ATPs, right? And so if we count all those things together, how many ATPs can we produce? 5 turns. Okay, you can work it out and then tell me what you think, and then I'll take it up with you. And then that will be it for today. We have 5 more minutes. Let's hope the fire drill does not go off in the next 5 minutes. Yes, that's very good. Anyone else? Good try. Try again. Good. Anyone else? Usually this is where people avoid eye contact. Like, don't look at me. Not quite. All right, let's take a look. Right. I mean, like, obviously you have to memorize the numbers for the test to do something like this. But let's take a look at one turn. Okay, one turn. How many NADH do we produce in one turn? Look at the summary and tell me. One turn, one turn. Two circles is called two turns, okay? One turn. How many NADH? Yeah, let's take a look at it together, okay? One turn is 3, right? This is called one turn, guys, okay? That's called two turns, right? So one turn is 3 NADH. So let's write that down. 3 NADH. What about FADH2? How many? One turn. One. Okay, does everybody know where I get these numbers from? Yeah? Okay, give me a nod if you know. Yeah. Okay, great. How many ATPs do we produce directly from the one turn? Look at the bottom of the turn. How many ATPs do we produce? One turn. One turn. Let's see. One turn. How many ATP, guys? One. Are we together? I'm a little bit skeptical, okay? Let's do this again. One turn of the Krebs cycle will create 3 NADH, 1 FADH2, and 1 ATP. Okay? Now you might wonder, like, why? Where do we get these numbers? Don't worry about it, okay? That's just, we can just take it for granted, okay? So, 3 NADH, 1 FADH2, and 1 ATP directly, right? Okay, now stay with me. Where do these things go? The NADH and the FADH2, where are they going to go in the reaction? ETC, right? They're going to go to stage 4, right? That's where we're going to make most of the ATP, right? I haven't tell you exactly how to do that. However, I did tell you that each NADH can make up to how many ATP? Take a look at the notes. Okay, we roll it down at the beginning. And I highlight it in pink and said important. How many ATP does each NADH produce? 3. That's right. So we're going to times 3, right? Okay, 3 times 3 is? Okay, yeah. Okay, otherwise I'm going to have to talk to your math teacher, okay? And then over here, what are we going to multiply by? 2, okay? Now, if you don't know where these numbers came from, it came from the important section, okay? If you didn't know that, know it for the test, please. So 2 times 1 is 1, right? I wrote it wrong here. Sorry, this should be ATP. I got too excited. And then, how many ATP here? 1 ATP. Oh, 1 times 2 is 2. I got to talk to my math teacher. 1 times 2 is 2. Okay, thank you. 9 plus 2 plus 1. What does that give you? 12. That's right. 12 ATP. That means for each turn, you will produce 12 ATP. Okay? Which means how many are you going to produce in 5 turns? 12 times 5, which is 60. Okay? This is per cycle. So 12 times 5 equals to 60. Do you understand? Okay? Very important that you do. And don't just memorize it, because like I might ask you like, some other number, right? Okay, very quickly before you go, what if the question says, how many ATPs can you produce from Krebs cycle with 5 glucose? Instead of 5 turns, it says 5 glucose. What's the answer? 120, that's right. Because 1 glucose spin twice, right? So it's going to be double the amount of turns, which means you're going to get double amount the ATP. 60 times 2 is 120. Okay? That's it. Thank you. Don't be late for Monday. Okay, I'll post an announcement. All right. 10% for every 10 minutes that you're late. Okay. Not for the whole group, just for the people who are late. Okay. So please be on time. And don't wear nice clothes because the beetroot juice are going to be all over the place.